All right, everyone, welcome back. So as promised, we are going to continue on with the battery series here. I've got 3 of our EcoFlow River Pros here, currently in a torn down state so that we can see the battery in all of these. Just like we saw in the first video, they're all laid out very much identically and very easy to get to. So we have the 0 cell all the way up to the 8 cell, allowing us to go ahead and get some voltage readings off these batteries. Now I went ahead and pulled these out. I did go ahead and disassemble them down this far, and I did go ahead and put my voltmeter on the batteries just to take a look and see what we're working with. And we actually have a little bit of an interesting case here. So this is the battery that we first tore down in that first video. So no changes there. The voltages haven't changed any from the last time that we saw this a couple of weeks ago. And that's expected. These are pretty low at this point, and they're really not going to continue to get much lower except for over a very long period of time. The second battery in the middle here is actually very similar to this one as far as the voltages, although it doesn't have a cell that is significantly below the others like this one did. So this one, whenever I take a look at the full pack voltage on it, it actually comes out to a little over 7 volts. And we'll take a look at that here. Hopefully I'll be able to zoom in on my screen right down here for you all. But we look at when I go from cell 0 to cell 8, and I got to kind of poke in here a little bit because this does have some water resistance on it. So I'm getting 7.02 volts, so not much over 7 volts, but a little bit. And again, it's very, very similar voltages throughout. They're between 0.9 and 1.1 volts on every cell here. So that tells me that these, again, went down at a very controlled rate. Because of that, I've got some hopes that I'm going to be able to bring this one back even more so rather than the first one that we tore down. Now the next one here, and reminder, all 3 of these, they did not turn on. So pushing the button on the front of the unit itself showed no life. In some cases, I've had a couple of these where I had to push the button a couple of times to get them to turn on. Same thing, nothing was happening here. Did a couple of reset procedures. None of these wanted to function. But when I take a look at this battery here and go from cell 0 to cell 8, I actually get a total of 27.7 volts. Very, very close to nominal voltage for this 28.8 volt pack. So what that tells me is that this one may have a more serious issue, or it could simply have an issue with the controller board and it wasn't getting the turn on signal. Now on each of these BMSs, there is a physical push button, and that physical push button does manually reset the BMS. I don't know if you'll be able to hear me clicking it here, but you push that a couple of times and that will manually reset the BMS to a working state if it is completely turned off, as long as the voltage is there. Now on the 2 units that have only 6 volts, pushing the manual reset does absolutely nothing. On the unit that has 27 volts, pushing the manual reset should turn on the BMS. We should actually get a little green LED that flashes at us when that happens. I haven't done it yet because once you turn it on, it doesn't turn itself back off for a substantial amount of time, and I didn't want to kind of ruin the surprise. So we're going to go ahead and do that now and see if we do get that green LED. If so, I may be able to just simply plug a new control board into this and have a working unit. At 27 volts, I doubt if there's any battery degradation at all. It really should turn back on and just accept a charge business as usual. So let's see what happens here. I'm going to go ahead and move our 2 dead units out of the way just a little bit. Again, we have battery cell 0, 1, 2, 3, 4 on either side here, 5, 6, and 7 and 8. So those are our banks of cells here. When I tested them individually, they all had between 3.7 and 4 volts, which again is nominal for these packs. So I would expect that this one would turn on just by simply hitting the BMS reset button, which is right up here. So I'm going to go ahead and do that, and with any luck, we will get a green LED light that flashes, I want to say it's just about right there, and be good to go. So let's see. Oh, so I pushed it, and I don't know if you're going to be able to see this because my overhead lighting is right here, but let's take that down. you may be able to just make out there a flashing green LED right there. So that actually tells me that this pack is currently live. It is ready to go ahead and output voltage. And if we test the voltage across the main lead that goes into the inverter, if I go ahead and put my negative to negative, positive to positive, we should now see exactly what I wanted to. 27.7 volts is coming out of this battery. So that tells me here, this battery is actually, it's good. There's nothing else that we're gonna need to do to this pack. There's no charging or special charging method that we're gonna need to take. This one really is just ready to go. So what I wanna do next on this particular battery pack, after zooming back out a little here, let's go ahead and bring the lights back up. And I'm going to grab a different front board. So this is the one off of the first unit that we took apart. And I want to go ahead and plug this in and see if we do get any signs of life out of this battery pack. So to do that, I need also an inverter board. So in my experience with these units, the main board, the main inverter board rather, is usually pretty rock solid. They do have a little bit of water resistance or waterproofing coating rather installed on them. So even if it did get a little bit of liquid, I wouldn't have expected that anything would be wrong with any of these main boards. But this unit didn't turn on using the main board that it came with. So I'm going to go ahead and use the inverter board and the control board off of the first unit that we took apart to see if we can go ahead and get this back up and running. So for that, there's a couple of main connections that we're going to need to make, and we're going to do this as a bench install. So we're going to do it outside of the main unit here, and then in a very sketchy manner to make sure that we don't touch any of the electronics here that can kill us. We're going to go ahead and put this all back together and verify that it is working when all back together. So first thing I'm going to do is go ahead and connect together some of our connectors from the inverter board to the main controller board here. Again, at this point, this unit hasn't, at least as far as I know, unless I have some gremlins that came into my shop while I wasn't here, this unit hasn't been turned on or powered on in a way that it's going to have any residual charge or voltage left in it, so I'm not worried about hurting myself currently. Although as soon as we plug this battery pack into it, it will become a live board. And at that point, these capacitors are going to charge up. There's a very good chance that we're going to, at that point, have a pretty high amount of voltage coming out of this, and we need to stay away from it. So again, don't try this. Don't try it at home. Don't try it if you think you know what you're doing. Just don't try it. So I'm going to go ahead and plug in. This is again, a control cable. This doesn't carry high voltage. It's low voltage only and allows it to get a signal back and forth between the controller board here and the main battery to tell it to turn on and off. And then this guy is the one that does carry our main DC voltage and is going to electrify this unit. So I'm going to go ahead and plug it in, and what I expect to happen at that point is more than likely this board is going to immediately power on because at that point the BMS is already activated, it's ready to go. Main board should really just kind of power up and be good to go. And I'm going to verify here. I don't think there's anything I can do to fully power this down. No, now it's not flashing anymore. It's just full on. So I think I actually powered it up fully. Okay. Standby mode, I want to say, is probably that flashing. Let's see. We're going to more than likely get a little bit of a spark here whenever I connect this. XT60 connectors, unless you get the special ones that have spark arresters in them, they carry a lot of power and a lot of amperage all at once. So let's see. Making sure my fingers are away from everything that they need to be. Oh yeah, we got a pop. Hey, looky there. So we actually are powered up here. It's actually reading a voltage, I'm sorry, a reading out of the battery saying that there's 16% left. So based on that voltage that we saw, the 27, a little over 27 volts, that is considered a 16% charge. And this battery's good to go. Our DC does power on. If I go ahead and power on the AC, yep, we now have AC power flowing through this, going into our connectors here in, again, a very sketchy fashion because all of this is currently loose in a way that I can touch it. So we're gonna go ahead and power down the AC rail there. So at least I don't have any AC coming out here. I still have dangerous voltages up top here. Let's go ahead and power this off by pressing and holding. So So the standby state, I was a little wrong here, is whenever the LED is lit fully on. The on state is whenever it's flashing. So you can see even whenever I powered this guy off here, I don't know if you guys see it because of the brightness in here, but this LED is still on, indicating that there is still something going on with the BMS. It's still calculating voltages, it's still getting temperature readings and things like that. And that's exactly how these units die. So ultimately, because that little LED stays on, because it continues to look for the temperature sensors to be within the correct range, it's looking for incoming or outgoing voltages, these get left into a warehouse, they get left in a garage, get left in a closet somewhere, nobody charges them for a year or two, and then they pull them out thinking that they're gonna be ready to go during an emergency, and that's when they find out the unit no longer works. So again, that's how these things get to that low of a charge. Since we see that this one's working, what I wanna do now is go ahead and throw everything back together into the unit by itself, verify that it is still working, and then I wanna go ahead and plug it into AC power and see if it does go ahead and accept a charge. Because again, this wasn't drained below a critical level, I've got a good feeling it's gonna go ahead and just turn on, start charging, and we're gonna be working with another working unit here. From there, we'll go ahead and move on to our next units and see if we can get those back to life. That'll be at least a little bit more fun. So cosmetic covers are on, everything is put back together. Again, we are still on and functioning here. Everything seems to be working perfectly. It's turning on and off as it should. So now what I want to do is go ahead and plug in some power to this unit to verify if it is actually accepting a full charge. What we're going to do first though, because it is above a 15% battery charge, is I can go ahead and get the Wi-Fi connected here, and then we can do the software update, which should cure the issue of it charging, or discharging rather, too low. So I'm going to go ahead and do that now. Now to get these into a pairing mode for Wi-Fi, let's pull this down here. Hopefully you all can see this. To get this into a pairing mode for Wi-Fi, you have to press and hold the IoT reset button until the Wi-Fi indicator shows up and it beeps. Usually I turn the beeps off on these. I don't really care for them. They're a little shrill. But once we've got that done, then all we have to do is open up our EcoFlow app. And in the EcoFlow app here, you can see that I've already added a few different units. Again, these are the ones that I was able to go ahead and get working already. And this one is not one of those units because it hasn't connected to Wi-Fi before. So we're gonna go ahead and add in a new device. We need to find the device. This one isn't smart enough to pick itself up. This is before they did kind of like an auto pairing through Bluetooth. This one's all Wi-Fi based. So we're gonna go into our River Pro here. We've already turned it on. We indicated that it is flashing, and then it's gonna have us connect directly to the battery itself. All right, and it found the unit here, so it's named EcoFlow B214. Go ahead and tap on that. And what this is gonna do is it's going to connect to a network that this device is sending out. Then from there, it can communicate over the information for my Wi-Fi network here in the workshop so that this can connect to the local network, and then we'll communicate that way. All right, so it's connecting here, as you can see on my phone. So it's connecting this device to my local network, and then from there we should be able to see the device and go ahead and do those software updates. So we've connected successfully. From here, we're gonna go ahead and add it to our workshop space because that's where I'm currently using it at least. And it immediately pops up and says, hey, there's a software update available. Do you wanna do it for this unit? And that's what we're trying to get all of these units up to. We're trying to get it to this 1.2.5.35 software update. So we're gonna go ahead and click on update. So it is telling us right here, current version of this software is 0.1.0.0, which is what I've seen on all these units. They came out of the box, out of the factory with that software on it. Nobody ever updated them, again, which causes the issue with the low batteries. We're gonna go ahead and do that update here now. All right, so the unit has finished downloading the software at this point, and it's simply applying the upgrade. We see that because it says up on the screen here. Now, in my experience, it's gonna go ahead and power off here in a second, and it's gonna force us to reconnect to that network like we did a moment ago. And that's because of the way that the communication goes with this new software version. So we're gonna be updating 2 bits of software here, one for the main control board and then one for the BMS inside of the unit as well. So we will see 2 different software updates. This one should be done in just a few moments here, and then we'll continue on with the second software update. All right, fantastic. So the software update, first one completed successfully. We're gonna go ahead back into the unit here itself. It does still show connected to my Wi-Fi, which is a little different than the other units that I've had this connection or this update with. I'm gonna go into the menu though, and then scroll down to my firmware. And yeah, it's actually telling me that it is on now the latest firmware without having to go through the extra steps of reconnecting it. Little weird for me, but hey, I'll take it. So now that we're on that latest firmware here, we can go ahead and see some more details about the battery itself. So this app here shows you what is currently activated on the battery and what is deactivated, and allows you to remotely manage those. So if, for instance, I wanted to turn the light on remotely, I can do that straight through our Wi-Fi here. Now you can also turn on and off the different ports, like the DC power port here, which will then turn on your DC power. And you can also turn on your AC power and verify what is coming out of that. So we've got AC power on and off, and I can hear the unit click on the inside, indicating that that inverter is turning on and off. You have a couple other settings in here you can mess around with. You can see the temperature of the battery pack itself and change the fan curve to turn it all the way up or all the way down. It also will show you if anything is plugged into the battery pack, how much voltage or wattage that device is using. So for instance, if I take a USB-C to lightning cable here and plug it right in, and then plug the other end into my iPhone that I use for my B-cam, you'll see that we get an output wattage here. It shows right now that it's coming out at 2 watts. The app shows that as well, 2 watt out. It'll renegotiate and go up a little bit here in a second. So yeah, we've got between 5 and 7 watts going out. Phone's almost fully charged, so it's not gonna charge super fast right now. But it then shows us that we can charge this at a solid 5 watts for the next 20 hours before the battery depletes the rest of the 16% that's currently in it. So pretty neat, and it shows you those statistics no matter what you have plugged in. And it is going to go ahead and show us more details on the app, of course, but right on the main screen also shows you exactly what you need to know there. So I'll go ahead and unplug that. Now that nothing is plugged in and all we're doing is powering the screen, it shows 99 hours, which is the maximum amount of time that it shows on this unit at any given time. So that will kind of just be like the default that we see there. So now that we've verified we have one good working unit here, we'll take a look at it on the charge a little bit later, but I'm interested to get into the 2 units that we have that aren't working and what we can do about getting those up and running. So we'll go ahead and put this guy off to the side and bring up the first of our damaged units. And this is going to be the one that we took apart previously. And I just realized something actually. So this is the unit that we took apart previously, and the only reason that I know that is because I did remove the external charge port here. I didn't realize the last time that we were in here that I see what happened here. Okay, so if I recall correctly, a couple of these units, they came in with a little bit of cosmetic damage on the outside of them. And I think this is one of them that actually got dropped at some point, because the bracket here that holds the battery down is damaged, and underneath it, the plastic is completely cracked away, and I have this screw. I'll have to go back to my previous footage to see if that's damage that I did or damage that it came with. But that might mean that we end up swapping this battery, if we can get it working, into another shell so that it's not just kind of flopping around in here, because that's unfortunate. And I can tell with how this is kind of dug into the plastic here, this is something that's been going on for a little while, so it's not I don't think rather that it's something that I did to it. But yeah, it's kind of unfortunate that they would use plastic to hold that in. I guess once everything is on top of it, there's really not much movement or ways for it to get out of there. But the first kind of thing that I've seen that's a little lacking here on these units. So now what are we going to do with this unit? We know that there's very, very low voltage across the board on this one. So what my intention here is to do is to go ahead and hook up a DC power supply with a very low regulated current and try to go ahead and feed some voltage in. We're going to first try and just feed 20-ish volts across the terminals here from 1 to 8. That's going to go ahead and distribute electricity throughout the device, in theory allowing all of the cells to pull up and allow us to actually get some voltage in here so that we can get the BMS turned back on. So for that, I need to go ahead and get our bench power supply. So when I was originally working on these units, the few that I was able to get powered up before wanting to go ahead and turn this into a video series, there was a couple of ways that I was attempting to charge the units. So I did have a USB powered 18650 charger, which again, 18650 is the batteries, the cells that are in these units here. And I would go ahead and I basically stripped the wires off of it so that I could solder it directly to 2 points. I'd plug it in for maybe 15-20 minutes and then move the wires over to the next set of cells, plug it in, wait 15-20 minutes, move it over, and try and get everything brought up to an even level using just the single charger. That obviously takes a long time. You're working with just the 4 volts, and it was only a half an amp, a 500 milliamp hour charger. So it charged very slowly and required a lot of intervention during that time. So what we're gonna end up doing, so that I don't have to sit here and hold my hand on the charger the entire time this is going, is I'm gonna go ahead and strip some wires and solder them directly to the 0 and 8 battery posts here. So I'm just using some zip cord for this. It's, I wanna say it looks like about an 18 gauge wire. Nothing super heavy because again, I wanna go at a very, very low charging rate here. So my expectation is that I don't need a heavy gauge wire. Again, the amperage that you charge at is what is going to determine the wire size. You can put any voltage to an extent through a wire as long as it is a low enough amperage. When you start really upping the amperage on there, when I start trying to put a lot of watts or a lot of amps into the battery at the same time, that's where you're going to run into some issues with that amperage is going to cause an excess of heat and will end up essentially melting your wire. Every wire is rated based on its size to handle up to a certain amperage. And that's what we're worried about when we're doing this. So for this, 18 gauge should be just fine. Don't plan on going more than probably an amp across this entire battery pack here. So I'm gonna go ahead and power up my soldering iron here. I've got a pine sill soldering iron, which I have plugged into our normal USB-C adapter. Going ahead and getting it turned on. It powers up very, very quickly. And then my little homemade solder station here. We're getting up there in temperature already. We just hit 350 at a little over 30 watts. And with this tip on there, I should be able to get this heated up relatively quickly. Not my finest work when it comes to the joint there, but it will in fact work, and it's on there. It's not going anywhere. I could probably pull this entire battery using just that joint there. We're gonna do the same thing over on the other side without crossing my solder over the terminals, because I really don't want to short this battery out. The BMS would protect us, but only if you're shorting out the main connection here. If I short this battery to battery right now, the BMS really isn't going to do diddly for us because there's no breakage of the connection in between the individual cells. It's a little bit better, and yeah, that copper's just wicking the solder right up. Beautiful. All right. So I've got 2 good connections on there, cleaning my tip off. And we'll unplug the iron here. My little solder station here is 3D printed plastic, not necessarily known for holding up to heat well. So the part of my soldering iron that goes through this doesn't actually get that hot. So as long as I let it cool down for like 2 seconds, it's good to go, and I can go ahead and put it out of the way. All right, beautiful. So we've got our connectors on now. I've got 2 connectors, a positive and a negative here. Those 2 connectors I can go ahead and connect to my power station here, our negative and our positive. Let me go ahead and first turn my output on, make sure that I've got the right voltage selected here. I think we do, actually. Okay, yeah, so we're currently at 8.4 volts, it's telling me. So we're gonna go ahead and slowly ramp up the amperage here. I've got 0.1 amps, which is 1 watt going into this battery right now. 1.2 watts. All right, so we're getting about 1/4 of an amp into it right now. I wanna go ahead and see what that's relating to as far as the actual charge of some of these devices. I'm sorry, of some of these battery packs. So yep, 1/2 watt, not a ton of voltage going in there right now. Let's see what we're looking at though. So if I go from battery 0 to 1, if I actually get a good connection, okay, 1.8 volts, that's something. 1 to 2, 1.7 volts, that's something. 2 to 3, 1.2, that's higher than it was. I'll go 3 to 4, 1.8, 4 to 5, 1.7, 5 to 6, 1.6, 6 to 7, 1.7, and then finally 7 all the way to 8, where we're getting our charge in right now, 1.8. So we are getting the, right now based on the voltage I'm putting into it, 13.58 volts, that's correct. And it is very, very slowly bringing this charge up, where again, it's based on what the unit is telling me here at 0.015 amps, which is practically nothing. It's less than 1/10 of a watt, or I guess just over 1/10 of a watt. So almost nothing going into these batteries, and that's exactly what I want. I don't want to stress these out, and I don't want to bring them up too fast. Now, why don't we want to bring them up too fast?
Hey guys, Editor Fo here. So I went on a little bit of a tangent here and got a lot of information wrong because I was going off of memory. So I'm going to cut in a little bit of audio here to give a better explainer of what's going on inside of this battery. So imagine a 18650 battery like a tightly wound roll of paper towels inside of a metal tube. At the very heart of the cylindrical cell, we have a few key ingredients. First, there's the anode that's usually made of graphite, and it's the black material that you see here in this video. Think of that as the negative side. That's where lithium ions hang out when the battery's fully charged up and ready to go. Then on the other side, you have a cathode. It's the positive side of the battery. It's generally made of a metal oxide. Now, separating these two is a very, very thin, and I'm talking thinner than a human hair, sheet called a separator. It's super important because it is permeable, so it allows the lithium ions to pass through, but it also keeps those two anode and cathode from touching each other, which would cause a short circuit in the battery. Now, all of this is soaked inside of a fluid. It's called electrolyte, and that is essentially what allows the lithium ions to move back and forth between the anode and the cathode. It's kind of like the roadway that it uses to get back and forth. Now, when you're using a lithium battery, and this applies to pretty much all lithium batteries, we're not just talking about these kind of cylindrical cells, the lithium ions basically come from the anode through that separator cell to the cathode, and that transfer is what creates the electricity. And just like when you use the battery, when you charge it, the opposite happens. So you're essentially just moving lithium ions from one side of the battery to the other and back the other way. That's how you charge and discharge a lithium battery. Now, when you repeatedly discharge a battery to a very low level, or if you charge it too quickly, or to a level that's too high, something strange can start to happen inside of the battery chemistry. Instead of smoothly redepositing the lithium onto the anode, some of those lithium ions can actually start to kind of stack up unevenly. These uneven spiky growths are called dendrites. Dendrites can grow and grow. They can literally push their way through that delicate separator layer. When that happens, the anode and the cathode touch. And what happens if the anode and the cathode touch? You guessed it, a short circuit. So a short circuit can generate a lot of heat, which can lead to something called thermal runaway. Thermal runaway is essentially a chain reaction where the heat just keeps building up, leading to overheating. That can cause the battery to swell, and in extreme cases, the battery can catch fire or even explode. That's why you sometimes hear about phone or laptop batteries having issues. So ultimately, how do we avoid these dendrites? The best advice is to avoid fully discharging your devices all the time. Try to keep your battery somewhere between 20 and 80% if possible. So there was a concern for a long time that these kind of batteries, if discharged even one time fully, could cause dendrites to build up. And in the early battery chemistries, that definitely could happen. Those kind of batteries, when discharged fully one time, very easily could short circuit themselves and generally were never able to be brought back to life. Now, battery chemistry did change over the years, and we've got much more resilient lithium-ion batteries these days that have a chemistry made to avoid these dendrites. So my hope, again, with these units is that we're going to be able to get these charged up slowly enough to avoid the formation of those dendrites so that our cells are still healthy enough to get a good life out of them. They might not last as long as a cell that was never abused this way, but they shouldn't give us any kind of issue with, again, that thermal runaway or with the batteries being short-circuited themselves. All right, that's it for my little side tangent. We'll get back into the video now.
So what I'm looking at here now, since our story is done, again, the reason why we're charging these so slowly is to avoid that dendrite formation and avoid the cells from essentially nuking themselves. So we're really just going kind of on hopes and prayers here that this doesn't decide to just catch fire. So far, it appears to be taking in voltage and wattage appropriately. We're down to 0.37 amps, a very low amperage again, so half watts going into it. I'm going to bump the voltage up again to see if we can go ahead and get a little bit more out of this. We're up to 16, 17, just over 18 volts now. Again, we want to get it up to around 22 to 23 before it's even going to turn on the BMS here. So we're still working below what the BMS is going to see. At this point, if I push this button, we don't get any kind of LED light, which makes sense to me. That's what I would like to see at this point. All right, so we're pumping half an amp in there at 18 volts. We're still good on our wires. There's no heat buildup or anything like that. At half an amp, I wouldn't expect that. This kind of wire should be able to take, let's see, off of memory, 18 gauge wire should be able to take between 6 and 7 amps before it starts to get warm. So we're gonna let this charge again, wait for it to come up to that 18 volt range, and then we'll bump it up a little bit more and just continue to slowly ramp this charging up. All right, everyone, welcome back. Only been a few minutes here since we last connected, maybe 10. So I've been slowly building the charge up in these cells. Again, just going ahead and essentially just turning my power supply up little by little, 1 to 2 volts at a time. It then determines how many amps it needs to put through the cells to get to that voltage. And so far, the most I've seen is about 10 watts coming from this unit. Right now, it's pulling 5.5 watts. And we're at 21.5 volts. And that is usually around the 20 to 22 volt range is when I start to see the BMS turn on. And that's exactly what happened in this case. So we may be able to see here, right there is our little green LED light. It's currently on full time. And if I push the button to activate the BMS, it does flash a few times, as in, assumedly, it's actually giving us some output voltage here, and then it goes completely solid. And I've seen that before. That usually is just because, again, it's really, really low, so the BMS isn't wanting to turn on quite yet, but it has enough power to at least recognize that, that it is able to turn on. So I'm going to take a look and see. I don't expect to have any voltage out of here at all while that is showing a solid green light. But let's go ahead and put our DC voltage mode on. Yep, nothing coming out of there, but if I go ahead and turn it on, now our light should be flashing here in a second. Maybe not, maybe it is, oh, there we go. Now I've got a flashing light, but still no voltage coming out of the unit. So it's not actually activating the output current here, which again is telling me that it's just so far below that charging voltage right now that it's definitely not even gonna try and turn on. So the fact that we have a green light on the BMS is a good thing. That means that our BMS is coming back to life. Still not out of the woods quite yet. We still need to go ahead and pump some more juice into this battery so it gets up to the 24 to 25 volt range. And then the BMS should be able to take over from there. Now, one other thing that I wanted to show here is that cell voltage difference. Again, we're currently pumping a little bit of volts through. We're at 29.5 volts, 3.9 watts through this entire battery pack. So almost nothing. We're talking less than about half a watt per battery bank. But we're still able to get some readings off of the battery right now. If I go from cell 0 into cell 1 here, and get a good spot. Again, the waterproofing makes this a little hard until you get underneath it. All right, so I'm looking at 2.7 volts for cell 0 to 1. When I go to cell 2 to 3, that's where our problem was before. And I expect we're still gonna be lower, but hopefully not as much of a difference as what we had. So yeah, we're at 2.4 volts on this one low cell right now. Everything else is coming up to around the 2.7 volt range at this point, based on what I've seen coming out of here. So it's really just that one, but it is coming up. It is bringing up some voltage, and it didn't seem to go down whenever I unplugged the battery, or the power rather, going into the battery. So yeah, we're at 2.7 on every cell except for that one is only at 2.4. That's not a huge difference. I think that's something that we're going to be able to overcome. We may need to do some spot charging on that cell, or possibly just leave this outputting a set voltage for enough time, and then that cell may come back up to the same voltage as the other cells. So we're going to continue on this path here. We're again dropping down. We're at 3.2 watts now coming out of here. I may actually go ahead and just bump up the voltage a little bit. We're at 21.6 volts now, half an amp, 21.7. So not a lot going into this, still at half an amp, so we're still pumping about 10 watts into this battery. We're gonna let this continue on. It's probably gonna take about half an hour to get it up to a range where I'm comfortable allowing the BMS to take over by itself. And then we'll go ahead and rejoin at that time. All right, everyone, welcome back. It's been a few minutes here. I've had the battery pack charging for about an additional 10 to 15 minutes here. We're currently at 22.52 volts, and it's still pumping about 2.5 watts into the battery at this point. What I've noticed is that the battery BMS does appear to be coming on at this point. It appears to have enough power to function, but when I push the button here to activate the BMS, it flashes about 6 times and then it turns itself off. Now, what that indicates to me is that there is some form of a fault in the BMS, and it's telling it, hey, there's something wrong with this battery. I'm not going to turn myself on. Now, we know that when we cross all of the terminals, we're going to see what the output is coming up on my power supply right now, which is 22.52 volts. And that's almost exactly what we see here, 22.56. When I take a look at each of the individual cells, again, going from cell 0 to 1, we see 2.89 volts, 1 to 2, we then see 2.87 volts. 2 to 3 is where we start to run into some trouble. So 2 to 3, again, just like we saw before, is our low cell, or our low pack of cells on this battery, and it's at 2.49 volts. So 2.5 versus 2.9, we're a 0.4 volt difference between that, and pretty much every other cell pack in this, or every other cell in this pack. We're at 2.9. Going from 4 to 5, we're at 2.86, from 5 to 6. Again, very similar story across the board here, 2.79, so maybe a little bit lower, but not significant. So what the BMS is looking for here is it wants us to be about 0.1 volt difference between all of these cells. When it sees an outline, a variance outside of that, it really does not like that, and it's not going to turn on because of that. It's going to sense the imbalance in there, and it's going to assume that there's something wrong with these cells. Now we know at this point, at least I believe, based on my previous experience with these batteries, that the early cells and the end cells generally do have a higher voltage than these middle cells. These ones that are right here next to all of the components apparently do seem to drain a little bit more quickly, or at least a little bit more fully than some of the other cells. Now what I'd like to do is I want to go ahead, instead of continuing to charge the entire pack up here, which could cause us some trouble because we could actually get some of these cells above a nominal voltage because this one is so much lower, and it could actually cause damage to the cells that currently seem to be charging all right. What I want to do is go ahead and disconnect the charging at this time from the entire pack, and I want to focus just on the cell 2 to 3 area here, because again, that's where we're starting to see an issue with the voltage, and it is off from the other cells. So what I'm going to do now is I'm just going to take the cell voltage for the cells around that one. I know I just did this, but I want to make sure I'm very, very close to what it is current. So I'm looking at 2.89 volts right after. And right before this cell, we're looking at 2.87 volts. So again, the cell that we're on is 2.44 volts. So I want to bring that 2.44 volts up to approximately 2.8 volts. So what I'm going to do is change my power supply here, and we're going to go down to a constant voltage of 2.8 volts. So what I'm going to do now is go ahead and take this 2.78 volts, and I'm going to go ahead and put one end right here on this negative port, one end on the positive, and I expect I may get a little bit of a spark here. No, okay, good. It's not a high enough amperage that it's going to give me a spark. So we're now pumping 2.79 volts into this battery cell here. It's bouncing around on amperage a little bit, but it's between 2 and 3 watts right now that it's pumping into this cell. And we're going to allow this to continue for a few minutes here until it is able to lower the amperage down to about a 0.03 is what I'll be comfortable with. That'll tell me that we're very, very close to the expected 2.79 volts that we're pumping into this. And then we should be about on par with the other batteries here. All right, everyone, just wanted to give a little bit of a better view on what I was working on here. We are currently charging just the single cell. Again, we're charging between cell pack 2 and 3 on the board here. I have one alligator clip going on to the connector for cell 2 here, or the one that's marked 2 rather, and then 3, we just got it connected directly to the solder blob there. What we're looking at over on the power supply, pretty simply here, we're at 2.79 volts. We are slowly bringing this battery pack, or this battery cell rather, up to the 2.8 volts. Currently it's pushing about a half an amp into that cell, which is actually, it's not a bad amount of charge for a single cell. It's not something where I fear that it's going to have any kind of thermal runaway or anything like that, but half an amp into an 18650 is a pretty good charge cycle. That's probably about 1C or 1 times the standard cell charge. Now these 18650s, or rather 18650s in general, can range anywhere from cells that can take a charge from only a couple hundred milliamps up to cells that can take multiple amps at a time. So for instance, in a Tesla Model S, one of the older ones, those use the same type of cells before they switched to larger battery packs, or larger battery cells rather. And so those can charge at multiple kilowatt hours charging speed, whereas what we're looking at here is less than half of an amp, so a very, very small, or less than 1.5 watts. So we're talking about a thousandth of what you could potentially put into a large battery pack. Again, we're only working with one set of cells here. I believe, based on just some basic looking at how the cells are configured here, I believe that that's about 6 cells that we're actually charging up with 1.3 watts. So again, a pretty minimal amount per cell that we're talking about here. But again, just waiting for this to kind of come up to that 2.8 volts. Once we see that, then we can go ahead and see if the BMS will turn on. We can see right down here the little green light that's showing up. And if I do go ahead and push the power button here, it does flash a couple of times. Let me cover it, actually, it'll be easier for you to see. And then it goes fully solid, which again tells me that it is still sensing some form of a fault here. So we will continue on with getting this battery pack up and running, and I'll check back in a few minutes once we get above the 2.79 volts here and it's no longer pushing amperage or wattage into that cell. All right, everyone, so you might notice a little bit of a different configuration of the wires at this point. So pulling out the multimeter here, let me get it to the point where you can see it. Yay, glare. All right, pulling out the multimeter here. If I go back to between 2 and 3, where we previously had the issue, and move my hand out of the way so you can see it, we are now up to 2.786. It is unfortunately dropping. Let's see if we can see it drop here. It was pretty steady at 2.8 and then, yeah, 2.785. So it is slowly dropping. There's some capacitance still left in these cells. So it is losing a little bit off of what it was when I first took it right off the charge. Pretty standard for any kind of lithium cell. I wouldn't expect that to be a major indicator that we're going to run into a lot of issues here. I wasn't charging it all the way up to, or I didn't rather get it all the way up to the 2.83 that we had set on the power meter here. We were still pumping about half a watt into it when I pulled it off. So it makes sense that it would be a little bit under that amount. Now the next cell pairing that we had that had a little bit of trouble here was the 5 to 6 pairing, which again, we'll try to make this so you guys can see it, was only at 2.6. I now have it up to 2.80. Again, we've been pumping 2.8 volts at about 1.1 watts into it for a couple minutes here to try and bring that one up just a little bit more, just to make sure that they're all again within that 0.1 volts of each other. So at this point, I think we're pretty much close enough to hook at least a screen up to this unit, see if it will allow us to power it on and see what it is recognizing currently as the voltage amount coming out of the battery here. So I have a display here. It is showing 0% charge. It's definitely thinking that it's very low. At this point, it was not showing a indicator of a bad battery. There's a faulty battery indicator that shows up on these. It flashes a symbol of a battery a few times and then it cuts itself off. That's good news in my opinion. So what we're gonna do next, I know for a fact that at this low of a state of charge, it will not kick on the AC charger. So there's not gonna be any way for me to get any charge out of that side of the battery, but it will allow a DC charge in. So what I'm working with here, some of you may recognize this if you grew up in the early 2000s. This is a power supply. You may even know a little bit more now just based on what we're seeing right there. But this is a power supply from an Xbox 360. And these things are great because they have a very, very strong 12 volt output. And if you do some wiring trickery inside of the device, you can hook up an XT60 connector. Woo, there we go. Sorry, my camera's upside down and backwards for me. We can hook up an XT60 connector to the end of it and allow this to then charge a device like our power bank here directly through its standard XT60 connector at a pretty high rate of charge. So I'm plugging this in right now. My power supply is green, indicating that it is outputting the 12 volts that we need. Let me go ahead and turn on the unit. Now I am getting a recharging. It's got an input wattage currently of 42, 48, 54. This is gonna max out at 100 watt input on the DC charge side, and we just hit it at 99 watts and then it backed back down. But we are actually getting a charge. It shows a 0% state of charge currently. Let me see if I can make that so you all can see it. There we go. It shows a 0% state of charge and it tells me it's gonna take 11 hours to charge it up right now at 50 watts. It's gonna continue to fluctuate here as it starts to balance out these cells a little bit. But the unit is actually charging on its own right now. I'm not, I don't have my other power supply hooked up. You can see the leads are just kind of hanging out here because I didn't want to disconnect them right away. But we now have this unit charging itself. And that's great news. So that means that this one, I'm gonna leave it on for a little bit of time and we're gonna wait for it to get above, I believe it's 15% battery charge that it needs to do the software update that's necessary on these. And then from there, we can go ahead and reassemble it and should be good to go. So we're gonna leave this for a little bit. It's gonna take a while to get up to that 15% charge. Once it gets to about 3% charge, I can then switch it over to AC charging. And it will charge, instead of at 61 watts here, it will charge at approximately 650 watts. So that'll give us a lot more power going into this. It'll charge much more quickly and get us up to 15% pretty fast. So I will check back with you all here in just a few minutes once we've got that rolling, and it looks like we might have saved another battery pack. All right, guys, one more quick update. Battery got up to 6% and it did actually pop a firmware update. So it looks like there is, like I said originally, there's two different versions of firmware on each of these devices. And it did pop the second one, forced me to go ahead and reconnect it to the Wi-Fi so that it could upgrade it, and it's doing that right now. It doesn't show upgrading on the later firmwares, it doesn't show upgrading on the screen, so there's really nothing for me to show you here other than what you're seeing here on my cell phone, just again, indicating that it's upgrading the firmware. I'm hoping that once it gets done with that, it's gonna give me access to turning the fan on, because I noticed that these heat sinks are getting kind of warm, but there's no option to turn the fan off of automatic mode before, I'm guessing, this firmware update goes through. So hopefully once this goes through, I can go ahead and pump that up so that we can get some real charging coming through. It's still only charging at 92 watts coming out of DC, and it really should be pegged at 100 watts there. So again, interested to see how this continues and progresses on. I will update you again as soon as I have some news. Looks like the firmware update just finished up, so it should be reconnecting here in just a second. I've got a flashing Wi-Fi icon on the device. It is now solid, indicating that it connected. I'm just gonna refresh and there we go. So there's our River Pro again. So it's actually telling me that the firmware update didn't complete. Let's see if it'll let me go back through. I haven't run into this error before. So let's go ahead and once again do an upgrade here. Now this time we did get a little bit of a difference on the screen. The screen shut off and now the power button, or at least it was just flickering. There it goes again. So it is doing something a little bit different this time than what it did last time. I'm assuming it's gonna go back to the screen where it just says up here in a second. At 33%, finally says up on the screen here. So as we're coming to the end of the upgrade here, something a little scary happened. Around the 66% mark, the battery pack actually showed an error on the screen, the flashing red battery error, which I've only seen when there was actually an imbalance in the battery that the BMS couldn't account for. It cleared up shortly after that, and it did obviously finish the update properly. So I'm thinking that that was just a fluke. Again, as it was doing the update, maybe it was resetting something because it didn't persist after the update. So now we're done with the update. We're once again charging here, and we're up to 94 watts, still only at 6% on the battery, and it says it's going to take 7 hours to get it fully charged from here. Now, one thing you may have noticed on that battery screen, and I'll go back to it here in a moment, it showed that the main update here was optimizing the charging curve. And again, that's been what I've seen with most of these units. Once you do the update, it charges without any trouble. So it appears to be good to go. I don't believe there's going to be any additional changes necessary for us to get this one up and running. I'm going to simply allow it to charge up. Now, the second battery pack I expect is going to be a very similar fix. So I'm not going to show that repair on camera unless there is anything that comes out or strikes me as being significantly different between the two. At this point, I want to get this one up to about 80% charge to verify it's working. I want to plug in a load to it, like one of my air conditioning units, just to verify that it's working and able to actually pull full power from this pack. And then I'll be comfortable allowing it to then just simply charge itself as it normally would and use it in a production environment. So I'm going to let this get up to about 15%. We will go ahead and rejoin once again, where we'll pull out the multimeter, test all of the batteries to make sure that the pack is within an acceptable voltage range that I'm comfortable with. After that, we'll allow it to then fast charge up to the full 650 watts and to the full about 80%. I don't like to charge these up to 100% because there's just really no need for how I'm using them. And yeah, we'll verify that we're working there. All right, everyone, back at it here. So we are up. I got a little over 15 actually, if you can see that, which you probably can't because I turned the lights back up. There we go. We're actually at 18% charge. So got a little bit on here, and that should give me a good idea of how balanced the cells are now that it's had a chance to kind of work its magic and hopefully balance them out better than I can just by holding some contact probes on there. So I'm going to go ahead and disconnect our charger. Battery pack still staying on, so no issues there. Not that I expected there to be any. I am going to go ahead and power it off by pressing and holding, and it should say off. We know from previous experience, though, that doesn't actually cut off the BMS. So there is still battery voltage going to this unit, and of course everything up top here I'm still going to treat as live. And then we'll zoom down in as well. All right, perfect. So now the last thing I want to do before I put this back together and consider it a pretty much done deal, first we need to go ahead and remove these two leads that I had on. If you ever start soldering a really large joint and you don't have enough power to just chug right through it, you always want to add a little extra solder onto the pad. What that's going to do for you is it's going to give a thermal interface between the tip of your soldering iron and the rest of the solder blob to then allow you to get it much, much hotter than normal. So very similar to how I'll relate this to computers because that's the other thing I seem to know. On a computer, you have to use a thermal interface material or a thermal paste usually. More lately, people have been moving to thermal pads because of some nifty technology brought out by Honeywell. But the thermal paste fills in all the microscopic cracks and gaps in the metals and allows the heat to directly go from one surface to another. So really make sure that you get a really solid connection there so that the heat can transfer. And that's the same thing you're doing by putting a little bit of wet solder on the end of your soldering iron. Let's go ahead and test these voltages now that we've got those leads removed. So I'm going to go ahead and flip over again to DC voltage here, and you all can see that. Perfect. So we're going to go from 0 to 1. 3.51 volts, that is beautiful to see. 3.52, so it's bouncing up instead of down, not bad. We're going to go from 1 to 2. 3.516, good voltage range there. From 2 to 3, this was our problem cell before. Oh, 3.502, that's not bad. 3 to 4, 3.518. Beautiful. 4 to 5. 3.517. That's excellent as well. 5 to 6 was slightly off before as well. Let's see what it looks like now. 3.515, that 516 even. It's almost identical to the cells next to it. Beautiful. 6 to 7, if I get the right one here. 3.516, again, perfect voltage for what I want to see here. And then from 7 to 8, I'll try and get my hand out of the way, but I've got to really get some, I got to poke this pretty hard, otherwise it doesn't make a good connection. 3.518, awesome. So just as a reminder for myself, what 2 to 3 looked like, 3.502. So yeah, it's close. It's within 0.01 watts. I'm sorry, volts, 0.01 volts. So that's, I want to say 10 millivolts. For my purposes, that's absolutely fine. Getting them that close is fantastic. So I'm going to, at least at this point, I don't want to get too far ahead of myself, but I'm going to call this one fixed. We're going to go ahead and get it on some AC charging to allow it to really get up to a full charge. Make sure that it doesn't drain itself overnight. That takes a couple of days, so hopefully I'll have an answer for you by the time this video goes up. If not, I will pin it in a comment because I'm currently working on this on Saturday and I expect to have the video out on Monday, and have a couple of other things that I need to get done in between that time. So the editing of this, let's see, I think we're on hour 6 of this saga now. Yeah, the editing of 6 hours is going to take a little bit of time to condense down and make it interesting. So from here, I'm going to go ahead and reassemble this unit. We'll verify one last time it's working, and then we'll be good to go with this one. And there we are, fully reassembled, still sitting at 18% battery here. I'm gonna go ahead and plug it directly into my AC power outlet here, and we're gonna give it a chance to stretch its legs and kind of see what kind of power this thing can take in. Now that I'm a little bit more confident about it, now that the batteries are better balanced than they were previously. All right, so if we take a look on the screen here, and I'll even zoom in pre-production for you, you can see that we're already pulling down 370, 300, 400, 20, 450, 470, 500. I'm gonna actually max out my circuit here in just a second, so it's probably gonna end up popping, but we'll leave it for a few seconds here to see. This can get up to 650 watts if it is given the proper cable and it has the proper inputs and all that other fun jazz. Right now it's sitting around 560, so still at this low state of charge, it still wants to kind of take it a little bit more cautiously. But that's a huge amount of power to take in at one time. 600 watts is going to get this charged, as you can see, in just over an hour. So yeah, great little battery pack here. We're going to go ahead and leave this one here. I'm going to work in the background on the other unit. If I find anything interesting about it other than what we found in this one, I'll go ahead and link that back in here. Oh, unfortunately, we just tripped the overload protection on my other power bank. I'll explain that in the next video when we kind of go over the capability of these units and how I use them. And then we'll take a look at a couple more to see if there are anything different between the ones that I have here. So far, they've all been very similar, where the batteries that are low are just simply low because of the long-term storage, and I'm able to kind of bring them back to life in this way. And hopefully we'll find something maybe a little more interesting in some of the other ones next time we convene here. So for now, we'll leave it here. Thanks again so much for watching, everyone. Please, if you want to keep up with this series, go ahead and throw a subscribe down below, and I'll keep you up to date on when the next video will be posted. I've got a couple other projects that I'm working on the side here. I'm trying not to leave too much time between these videos because I know there's some people that want to see what goes on with these EcoFlows and kind of wants a better idea of how it's going to work with the repairs. I've still got 6 more of these. Nope, I'm sorry. I've still got 4 more of these that we haven't taken apart yet and don't know if they're actually working. I don't think any of them turn on whatsoever, so we've still got a few more that we're able to go ahead and work on and play with. And that includes a couple of the backup batteries, which plug in right over here to this expansion power port. So that's, again, something pretty interesting, kind of a relic of the past, because it's not something where EcoFlow even provides the cables to use them anymore, but hopefully something that we can get some good use out of and at least take a look at and see how it works in conjunction with this main unit. For now, everyone, we'll leave it there, and I will catch you all back here on the next one.